Hello, everyone. My name is Verde Arbusto. And this is the Schumann Harmonics Resonance channel on YouTube and Facebook. It is the Tuesday, the 23rd of September, 2020. And I came across an interesting link I thought I'd share with you. And this is really actually just a really fun link. It has to do with sound. And you all know how much I like putting music and sound in these videos. This is take 2. It was a pain in the ass to remove the last 17 seconds of garbledness at the other one. It didn't look right after I was done editing it, and I was like, oh no, I'll just reshoot this. Okay, so what we're looking at here this is from the Chandra X-ray Observatory, which it says NASA's, what does it say here? NASA's flagship mission for X-ray astronomy. And this is a project called Data Sonification. And I'm just going to play it. Watch this. Mm, 104, there we go. All right, so, okay, so I got this from Suspicious Observers. I will leave you the link of his video just because I love what he does so much. All right, so what it says is, all right, cool. Here's the X-ray, the infrared, the optical. Okay, so they give you they have different instruments. Right, so the optical is a much different set of tones than the composite, which is the X-ray, the infrared. I'm not going to go through all that. All right. So I'll just read to you what it says here. A new project using sonification turns astronomical images from Chandra and other telescopes into sound. This allows users to listen to the center of the Milky Way as observed in X-ray, optical, and infrared light. As the cursor moves across the image, sounds represent the position and brightness of the sources. This project also turned astronomical images of the supernovae Cassiopeia A and the pillars of creation into sound. All right, and so I'm going to read through a bunch of stuff, and then I'm going to get to that one, and then that one. Okay? The center of our Milky Way galaxy is too distant for us to visit in person, but we can still explore it. Telescopes give us a chance to see what the galactic center looks like in different types of light. All right, and so they give you... Oh, wrong one, sorry. There we go. So, I'm not going to read this. I'll leave the link for this, but it says, X-rays, another form of light. All right. All right, back to our original text. But what about experiencing these data with other senses like hearing? Sonification is a process that translates data into sound, and a new project brings the center of the Milky Way to listeners for the first time. The translation begins on the left side of the image and moves to the right when the sounds representing the position and the brightness of the sources. The light of objects located towards the top of the image are heard as higher pitches, while the intensity of the light controls the volume. Stars and compact sources are converted to individual notes, while extending clouds of gas and dust produce an evolving drone. The crescendo happens when we reach the bright region to the lower right of the image. This is where the 4 million solar mass supermassive black hole at the center of the galaxy, known as Sagittarius A, which is A star, resides, and where the clouds of gas and dust are the brightest. Users can listen to data from this region, roughly 400 light-years across, either as solos from NASA's Chandra X-ray Observatory, Hubble Space Telescope, and Spitzer Space Telescope, or together as an ensemble in which each telescope plays a... I prefer it when that doesn't happen. Plays a what'd you just do to me? Okay, hold please. I'm gonna have to pause this. Okay, we're back. Users can, that's where we're at 400, that's where it was before, all right. So each telescope can play different instrument like I showed, okay. Each image reveals different phenomena happening in this region about 26,000 light years from Earth. The Hubble image outlines energetic regions where stars are being born, while Spitzer's infrared image shows glowing clouds of dust containing complex structures. X-rays from Chandra reveal gas heated to millions of degrees from stellar explosions and outflows from Sagittarius A. In addition to the galactic center, this project has also produced sonified versions of the remains of a supernova called Cassiopeia A, or Cass A, and the pillars of creation located in Messier 16. In Cass A, the sounds are mapped to 4 elements found in the debris of the exploded star, as well as other high-energy data. The distribution of silicon, red, sulfur, yellow, calcium, green, and iron, purple, are revealed moving outward from the center of the remnant, starting from the location of the neutron star in 4 different directions, with intensity, again, controlling the volume. There is also another version with 5th audio path moving along the upper left jet. Open that one like wow. Okay. Glad I clicked that. All right. So this is one of the main events, which y'all come here for. Bam. So you see the... And that other one we showed, the first one, the 5th harmonic, comes out there. The 5th harmonic of the Schumann is, I think that's the 33 mark, if I'm not mistaken. All right. So it says, explore solo. So you can look at the 4 of them differently. You had each one moving. I did the 5th. So you can see that. All right. In the Pillars of Creation piece, the sounds are generated by moving horizontally across the image from left to right, as seen in both optical and X-ray light. As with the sonification of the galactic center, the vertical position of the recorded light controls the pitch, but in this case, it varies over a continuous range of pitches. Particular attention is paid to the structure of the pillars, which can be heard as sweeps from low to high pitches and back. The two different melodies of optical and X-ray light can be enjoyed individually or simultaneously. So if you go there, you can select on that, so you can look at it, blah, blah, blah. So this one here. Right on. Okay. So then it says, I'll play this. It says, sound plays a valuable role in our understanding of the world and cosmos around us. Explore how scientists are using NASA's Chandra X-ray Observatory and other instruments around the world in space to study the cosmos through sound at the Universe of Sound website. We should go there. This sonification of the Galactic Center, CAS-A, and M16 was led by Chandra X-ray Center, CXC, as part of the NASA's Universe of Learning, UOL, program. NASA's Science Activation Program strives to enable NASA science experts and to incorporate NASA science content into the learning environment effectively and efficiently for learners of all ages. The collaboration was driven by visualization scientist Kimberly Arcand of the CXC, astrophysicist Matt Russo, and musician Andrew Santaguida, both of the Systems Sound Project. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory's Chandra X-ray Center controls science from Cambridge, Massachusetts, which is very near here, and flight operations from Burlington, Mass., also near here. NASA's University of Learning materials are based upon work supported by NASA under cooperative agreement, award number, blah, 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 to the Space Telescope Science Institute, working in partnership with Caltech IPAC Center for Astrophysics, Harvard and Smithsonian Jet Propulsion Lab, and Sonoma State University. Oh, good golly, that's a lot. All right. So where are we at? All right. So before I play the last video, I'm going to kind of have that as the outro. It shows here fun facts for the Galactic Center, the coordinates here, the constellation Sagittarius observation, just interesting kind of stuff. And then this is the range that they're measuring here. This right here is infrared. And this is an important chart. I want to show this here. Because this is where we're at with the Schumann resonances. The Schumann resonances are this band here. Very small, up to 50 hertz, maybe 120 hertz at the most. So maybe like here at the most. So this right here is the range of the Schumann resonances. From here on, this is all outside of the range of the Schumann resonances, and especially the optical light. The Schumann resonance antennas do not measure optical light, which would be that incoming white light that everyone talks about. Well, the Schumann resonance antennas don't measure that, okay? All right, and then here's more fun facts for Cassiopeia and the range that they're in here, right, way over in the X-ray range with Cassiopeia, this particular project here, okay. And then this one here, the M16, the last one, the pillars, which is very interesting. They have this two ranges here that they're using to for their instruments. Okay. Okay, panning out. Thank you. I'm not getting nervous here. All right. So with that, I'm going to play this last one, and this will be the outro coming out of here. So, if you like this video, make sure you subscribe, tell all your friends. Like, share, and subscribe. I appreciate any feedback. I like to answer whatever comments and suggestions you may have. Thank you all for being here. I appreciate your being here. I love you all very much. Thank you.